So today we're going to revisit the primary trigonometric ratios. In fact, we're going to be looking at a thing called SOHCAHTOA. We usually write it as this. SOHCAHTOA. Okay, now this thing here is called a right angle triangle, and with our right angle triangle, we have this special thing called a hypotenuse, and the hypotenuse is directly across from the right angle in our triangle. Now, hypotenuse only happens for the right angle of a triangle. Now, what we're going to do right now is we're going to focus on this angle A here. Notice angle A has side A directly across from it. Okay? And angle B has its side directly across from it. So if I have angle C in the right corner, that means side C is the hypotenuse. Okay? Now, remember, we were talking about SOHCAHTOA. The SO in our SOHCAHTOA stands for sine of the angle A is equal to, well, it is the O and the H stands for opposite over hypotenuse. If I'm looking for the cosine of angle A, what we're going to be using is the adjacent, which means the side that is right beside the angle. And that also means the opposite side of a triangle is always the other the other leg of the triangle, which is directly across from that angle. So now for cosine of A, we have adjacent, which is A, which means the thing that is beside the leg of the triangle that is beside over the hypotenuse. And then finally we have tangent of A, which is also going to be, well, take a look at our equation up here, TOA, which is O over H. Now, let's go and take what we have on our graph of this triangle here, and we will use the sides that we have for sine of A. So if I'm looking at this triangle, we have sine of A is O over A. So O is A, and H is the letter C. So we can write this as A over C. And now for cosine, let's do that again. So now we're going to do the adjacent. The adjacent side is this one here. Adjacent divided by the hypotenuse, which means the adjacent is the side B divided by C. Now for tangent, we end up with the side A over side B. So now what we'll do is we'll move on to the main concept of trig ratios. For part A, it says, write the trigonometric ratios for an angle. So when you hear the term ratio, we really mean this. We're looking for some form of a fraction equal to sine A, cos A, or tangent A. So now, when you see question 1 here, it says, write the trigonometric ratios for sine of A, cos of A, and tangent of A. So just like before, I'm going to basically highlight my little angle that I'm going to be using. So you notice how I put my little smiley face in that little corner. So the next thing that I have to do is I have to identify my opposite, my adjacent, and my hypotenuse. remember, our hypotenuse comes out directly across from the corner. So this is our hypotenuse, no problem. The question is, what is our adjacent? So you look at the angle where our face is, and you look for the leg of the triangle that's directly touching it. So if I'm looking at that triangle, that means this part here is my adjacent. Adjacent is another word for beside. So this is my adjacent. And this side here, this other leg, this remaining leg, is going to be my opposite. Just try to remember that the adjacent and the opposites are always, once you choose the adjacent, the other leg is always the opposite. So now, when we're looking for the sine of A, we know that the sine of A is using the acronym SOHCAHTOA. The SO in this thing really means sine is opposite over hypotenuse. And so we write O over H. So now that we have O over H, we can write sine of A, of big A, is equal to, well, the opposite side is 12 over 13. And we're done. And the same pattern can be used for cosine. So now remember, cosine is, well, in the ka, it's CAH, which means cosine A is A over H. And now we just use our triangle. So the adjacent is equal to 5, and the hypotenuse is 13. So we can write cosine of A is equal to 5 over 13. And we similarly get the same thing for tangent. And we write tangent of A is equal to, well, we go and take a look. TOA is part of SOHCAHTOA, so its tangent is opposite over adjacent. So we're going to write O over A. And then we go to our triangle and we look for the opposite, which is 12 over 5. And that is tangent of A. And that's all we're doing. We're just figuring out what the equation is for the tangent or the sine or the cos. And all we're looking for is simply the fraction. All right, pause the video and then we move on to the next section. So for B, we're finding the missing side when we have a given S and an A. So S and an A. The note S and an A means the S for S in A means side, and an A for angle. Okay, for this right angle triangle, we know we can use SOHCAHTOA, right? The question asks us to find the length of side A, and we're going to round our decimal to 1 decimal place. So let's go and label the sides in blue. So the sides are, well, this side over here is not B, it is A. This side here is B, and this side here is C. So now let's go and label all the adjacents, the hypotenuse, and the opposite. So this side here, C, is the opposite. So it's directly across from our right angle. So now, as for the adjacent, so you notice it says to find the length of side A. So side A is here. Okay? So that, but we also have angle A, which is this one. So I'm going to circle it. All right, so we have that side, we have that angle, and we have the side beside it, which is called the adjacent. And then this other side is the opposite. So now, when we're trying to solve this problem, we have to decide whether we're using SOHCAHTOA. Okay? Now, based on that, if you take a look at this, we have this side here, and we need this side. Okay? So that means we're going to use the TOA in our acronym for SOHCAHTOA. So that means tangent is opposite over adjacent. Now let's substitute directly in. So the tangent of A, so the angle A is 35. So we're going to write tan of 35 equals, well, here is our opposite, which is the letter A. So we'll actually write the letter A over, well, the adjacent, which is 10.2. Now, in order to make your life easy, what you want to do for this is we're going to take the tangent of 35, and we're going to use our calculator. And we're going to write tan of 35 on our calculator. And tan of 35 is going to turn into this 0.700, which is equal to A over 10.2. Now, in order to make our life easy, we're going to have to remember that any number can be written as a fraction of something over 1. So now that I've got that, that allows me to do some craziness. Okay? Now, that craziness is going to be a thing called cross product. So we're actually going to just basically link up the letter with the number. The letter with the number in this case on the left side is going to be 1a is equal to 0.700, and then we're going to times that by 10.2. So remember, with the cross product, we're crossing the top of the one side with the bottom of the other and the top of the one side with the bottom of the other. So now we have 1a is equal to 7.1 centimeters. Well, not centimeters. We can't say that yet. But now that I have the 1, now I'm going to divide both sides by 1 to get A to equal 7.1 centimeters as my final answer. And we're good to go. So for the next problem, we're doing the same thing again. You'll notice that immediately upon doing my new triangle, I write SOHCAHTOA in order to decide what we're going to use, whether we're using sine, cos, or TOA. So let's label all the sides. You'll notice that for this triangle, A, B, and C are on different sides of the triangle this time. The reason why I put that on there is because I want you to realize that for these triangles, A, B, and C can be in any corner. Now let's label the hypotenuse, opposite, and the adjacent. Notice the angle that we have here is angle C, right? So the adjacent is the leg that is directly touching C. So this is the adjacent. This one is the opposite. And then this one here is the hypotenuse. Now for this problem, you'll notice here, this is our angle C, right? And what we're looking for here is side A. So I actually want to find this side here. So let us highlight the side we want. So this is what we're looking for, okay? So now that we want that side, imagine you're going to do the calculation. You're going to write, well, I notice that I have a side here, and then I want this side. So we're going to use cosine in this case. So we've got cosine of C is equal to, well, A over H. And now when we substitute, we're going to get 4.1 over little a is equal to cosine of 38. Okay? Now, C is 38. Always deals with degrees. And all we're going to do is we're going to type in on our calculator cosine of 38. And then we're going to put that answer right onto our worksheet. And we get a decimal again. So we're going to get the following answer, 0.788 is equal to 4.1 over A. So now we do what we did before. Change 0.788 into something over 1. We'll do our cross product once again. And then we will do our calculation. So we got 0.788A is equal to 4.1 times 1. And now we have to get rid of the 0.788 on our A. And we end up with a final answer of A equaling 5.2. kilometers. And we are done. Now, looking back on this problem, you can see why it's difficult. The reason why it's difficult is because our A is on the bottom of our fraction. It's not like what we did before, where we had A on the top. But it still comes out to be the same calculations. We join up the diagonals, and then we divide out like we did before. All right, pause the video, rewatch this if you need it. So the next concept that we're going to do is we're going to try and find an angle, okay? So when you see something that looks like this, find an angle when we have SS. So SS means we have a side and another side, okay? So when you look at example 3 where it says, find the measure of angle A to the nearest degree. To the nearest degree, the nearest whole number degree. And this little symbol means angle A. So let's go and highlight angle A on our triangle. So this is what we're actually looking for in our little triangle. We have angle A being where our smiley face is, right? Now we have to identify what the two other sides that are known on our triangle are. So remember, SS means there's two sides of the triangle that we know, okay? In this case, from here out, we know that this is the hypotenuse. 13 is the hypotenuse. Okay, now let's go and take a look at the side that is directly across. Well, this one here should be the adjacent. So that means this should be the opposite. So what I'm going to do is I'm just going to get rid of that. And all we have is hype and op. So you'll notice every time I use this, I always write SOHCAHTOA with these right angle triangles. And I look to see what of our ratios use opposite and hypotenuse. And in this case, it refers to sine. So we have sine of A is O over H. And now we'll do our substitution for the two sides. So now we have sine of A is 12 over 13. Okay, so what I want you to do is I want you to write this now as sine of A is equal to 0.923. This will save us some time because some of you guys have a little bit of difficulty with fractions on your calculator. So we're going to use 3 decimals. 3 to 4 decimals for your calculations depending. So now that we've done that, the next thing that we want to do is we want to find angle A. So to find angle A, what we're literally doing is we're taking this sine and we're moving it over to apply to the 0.923. Okay, and in order to get a by itself, we're actually going to write the following. Sine with a little -1 means sine inverse of 0.923. In math, we say that sin with the little negative sign is, we say that this is sine inverse. On your calculator, we actually have to use the second function with the sign of the number to get that. So you're literally going to put second sine 0.923, or some calculators you'll have to actually put 0.923 second function or shift sine. And punching that into your calculator, you get the following. Angle A is equal to 67.4 degrees. And we are done as our answer. So now let's go and do this again. Remember, we're trying to find the measure of angle A. Now, I'm actually going to keep this note from the previous question here for us to see, so we can kind of have an idea of what we're going to do here, okay? And we still have our SOHCAHTOA. We can highlight that for when we have to use our calculations. Now, we have two sides in this case, right? Remember, we need to find the angle A. So this is what I'm looking for. There's corner A, so that's what I'm looking for. Now, let's look at the sides that we have here. So you'll notice that we have this leg here and this leg here. The legs of the triangle are the opposite and the adjacent. In this case, this side here, okay, because it is beside our angle here, we're going to call this the adjacent. And remember that the only other option for the other leg is the opposite. Based on that, I have SOHCAHTOA. So the only one that has the opposite and the adjacent is our tangent equation. So let's begin. So we start with tan is O over H. Now substitute. And remember from our previous example, all we did was we take our answer and turn it into a decimal to about 3 to 4 decimal places. So now we get 12 over 5 calculated to 3 or 4 decimal places is about 2.4. So tan of A is 2.4. Following the pattern that we did from before, we say angle A is going to be the following. And you get angle A is tan inverse of 2.4. So remember, you're going to have to use second tan of 2.4 or 2.4 second function tan on your calculator if it's an older calculator, and you end up with angle A equaling 67.4 degrees again. All right. All right, so now let's go back and refresh ourselves with solving right angle triangles. When you hear somebody say, solve that right angle triangle, we're actually saying this. We're finding all of the angles and sides of the triangle. So let's quickly do this triangle. Okay, if I'm looking at this triangle, this 30 is what I'm looking for, is what I have. I have an angle and a side. So I got an angle, and then I have the side C here, okay? And I have the adjacent side B here. So I might want to use tan. So using SOHCAHTOA, because I have A and C, I chose A and C. I could have chosen B. I could have chosen A and C, or I could have chosen B and C. So it doesn't really matter. You choose what you want, what side you're going to use. In this case, I'm using tangent. So now I've got the following. You'll notice it's tangent of side C because that's the corner that we're using. So we've got tangent of side C is equal to the opposite over the adjacent. So that means this is O over A. And it comes out to be tan 32 is equal to 6 over B. All right, we'll change tan 32 into a decimal. So now you've got 0.577 is 6 over B. Then what we will do is we will change 0.577 into something over 1 like before. Then we do our cross product again. And we end up with 0.577b is equal to 6 times 1. So that 6 is 0.577b. And then we divide both sides by 0.577, which means b is equal to approximately 10.4 meters. Now that I've got that, I will sequester this information off because we're kind of done that. The next part we have to do is we need to find angle B. So if I'm looking for angle B is 180 minus 30. And then that right angle on our triangle right here is 90 degrees. So we subtract 90. And we end up with angle B is equal to 60 degrees. That's great. So now that I've got angle B equaling 60 degrees, I'm going to put that away again. So we're done that. And then the last stage of our problem is either using sine or cos or hypotenuse to find our other sides. So I've got all these different sides here and angles that I've found. Let me go and put them on my triangle, and then I'll just see what's left over. So now I'm going to put in green here. So this side here is 10.4 meters, and then this is 60 degrees here, which means all we have to do is find this, right? Now, if you want to make your life easy, let's use Pythagoras Theorem. Let's use Pythagoras. Now, Pythagoras Theorem tells us that we have the following. H squared is equal to a squared plus b squared, right? Since this part here is our hypotenuse. Yeah? And that's all we're looking for. So let's just use what we've got. So we've got h squared is equal to 6 squared plus 10.4 squared, which gives h squared is 144.16. And then all we're going to do is we're going to finish up the final bit. So we end up with h is equal to the square root of 144.16, which means the hypotenuse is 12 meters. So you'll notice on my original triangle, I had to write everything that I knew or calculated in order to solve our triangle. So literally at the end, you have to say, so the triangle is blah, 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 blah. And a picture is worth 1,000 words. So if you tell me by showing me the triangle with all of its angles, that's good enough for me. All right. And now here is your homework. Your homework is going to be based on this. As usual, I'll be giving you some feedback, and I might ask you to tell me how you would solve a question like this last one. Okay, bye-bye.